The next factors in the equivalence equation are the uniform series present value and the capital recovery factors, P over A and A over P. And the cash flow to show you the relationship between the present value P and the uniform series amount over a period of time N, A, so A the same amount repeated over and over for N periods. So with that here, we want to find out the relationship between P and A. So in the real life, for example, when you buy a house or you take a car loan for the car, then that is P amount that get into your pocket for the house, for the car, etc. And then every month you have to pay uniform amount for the certain period of time. For example, 5 years for a car, 4 years, or for the house, 10 years, 15 years, for the market, 30 years. So that is the relationship. So when I borrow the P amount, how much I pay per month, that also a good practical application when you buy the house in future. So this basically realize and model that simple. And let's assume the I in this case is I percent given is I percent in there. So the question is, what is the relationship between the P and A and P? In the previous lesson video, I showed you to do by induction to find out relationship between F future value and present value, and then present value and future value. And I don't think we need to do that the same process with the induction. We just use the equation to show you here. So the equation to find out relationship between P and A. So given A, 5P, then I can apply P equal to A with a factor, and in that factor here, it equal to 1 plus I power n minus 1 over I 1 plus I power n. And similarly, that equation, I can realize that with the factor that I can use in the table. So it will be equal to A. That square bracket can replace with the A given. So it given A 5P. So P over A. I percent and years. And we can go back to the table that I show you in the reference. Similarly, if give you a present value, it means we borrow the money and how much I pay per month. So A, so that will be A become unknowns, P become given. So 2A given P, then you just flip the denominator become a numerator and vice versa. So it will be I 1 plus I power n over 1 plus I power n minus 1. One plus I power n minus 1. And if we use the factor in the table, it will be in that 2A given P I percent n. So that factor, I can go back to the slide again. So you can see the third column here, P over A, it means 2A given P. And if you go previous table, we can have on of that here. So we have P over A given A 5P, A over P given P 5A. So that's the equation you have, or the table you have, and how to use that in the table. But one note is very important here that normally we ignore how to find out A and P. And you can see, I say A is at the end of year 1. A start at the end of year 1 or at the end of month 1. So not at time 0. The first A is not at time 0. So to apply this equation, I make a very important note here. Don't forget this, to apply that equation. So it means P, the note here, P must always be located one period can be months or years, depends on the scale you draw your cash flow diagram. One period prior to the first A. Okay, so that very important, the first A, one period prior to the first A. So the first A here at year 1, then P at year 0, if you apply that equation. Make sense? So if it A, the first A at year 2, then the P in that equation is located at year 1, not year 0. So that very important note. Box that one. Box this note. Okay, so that applies to problem 2. How much money should you be willing to pay now for an investment that is guaranteed to yield 6,600 per year for 9 years starting next year at the interest rate 10% per year? So that we can draw the diagram very simple here. So also years, so the time scale is years for 9 years, so it will be 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And how much money should you be willing to pay now? So with the P unknowns, what is P? To have a guarantee to yield 600 per year for 9 years. Starting next year. Starting next year is mean at the end of first year or at the beginning of next year. So it will be here, the first one. Same amount. So it will be uniform. A equal to 600 per year. A stands for uniform amount. And the interest is given I is 10% per year. So given A5P, so we can apply that equation P over A. So we can use the equation or use table. Let's use the equation P equal to A given, and then apply 1 plus I power n. Then we can have that is one plus I power n, so it will be 1 plus 1, 1.1, because 10%, power n 9 minus 1 over I 0.1, 1 plus I power n 1.1.9, and from that we have equal to 3455.41. So if we use direct equation, we get that number. If we use table, so we have P equal to A, and the factor it will be P relative to A, 10%, 9 years, and equal to A 600, and we want to time what is that. So go to the table, table here, looking for 10%, 10% here, and we want P over A, so that column, and for 9 years, so as you can see that is 9 years, so that it will be 9 years P over A, so it will be 5.7590, and you can see there. So that we can go down to here, point no 5.7590, and that we can get it equal to 34.55.40, and that get the answer. Very close because we approximate. The table is more approximate in there. So we can use table or use the equation directly.